Okay, hello everyone, welcome back to my channel. So today we're talking about the stuff about the fundamental physics about the chapter 2. We're talking about the today section is the fundamental interactions. So in the Chinese we call it 交互作用. There's a force. Also, actually, there's in our high schools, high school class that we're talking about. There's some force. There are force information, very important gravitation. There are force interactions in our daily life. However, this daily life actually can be acted between the microscopics. So if we were talking about into the macroscopy, we will use the force to talking about these ideas. However, if we're talking about the macroscopy, microscopics, so we will use the phrase the interactions. Okay, so this is really important topics, the interaction vs the force. Okay, so the force in Chinese is Li. So and you can just go back to you can date back to the 80th centuries about by the Newtons. So the word force is proposed by the Newtons. However, that now we know that there's lots of action in the microscopics. So this is a different scale to talking about. And so if we're talking about the fundamental interaction, it means that we were talking about the macros, we're talking about the microscopic scales. So we will use the phrase interaction. So this is ideas that I think all of you should know that. Okay, so the first things we're talking about is the first interaction is the gravitational. And in Chinese we call it is the gravities, or maybe the gravity of the 重力. Okay, so it means that there are two particles. If there is a two particle over here, and two particle each particle has the mass, the m8, and this is the m8. Okay, so these particles have the distance between their centers, right? So these centers, the distance of them we call the r. So if we will find that this is the gravitational interaction over here is the constant m8 times mb over the r squared. Okay, so this is the gravitational interactions, very important topics. And now we will talking. This is really talk. So if we change the distance, you will cause the force will be the degrees, and if we cross the distance is cross it, and the force will be the increase. And also that if the product of the MAs times the MBs means that the bigger, then the value of the gravitational, or maybe what we call the gravity will be larger, and also the upside is just like that. Okay, so this is the gravitational interactions. However, that in the microscopics, here is the electromagnetic interaction. It means that if something have the negative and the positives, this is the Q, and this is the negative, and this is the positives that between that. Okay, so also this is R over here. So we find that this is the electromagnetic interaction here is that the Coulomb constant times the Q over the r squared. So you will find that the formula is much familiar like actually a familiar like that. So it means that there's some kinds of the force will be abide by some rules in the natures. So in the past, lots of scientists things they were really interesting about these properties. Okay, so one is about the mass and another is about the charge. Okay, so for the mass that we know that the idea is in newtons, and the charge actually is the charge. So the three is the strong interaction. So what's the means that is the strong interaction is that um, we can use this picture to explain it. Okay, so this is the nucleus. Okay, so in the nucleus there's some matter. There's lots of there's this is the proton, 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 proton over here, right? And there's so actually the proton will have this is the M, the neutrons. So the M is neutrons, neutron over here, a neutron over here. That okay. So um, in the region of a nucleus, that there's a large force. Actually, there's a large force. We call a strong force. Sorry, and there's large force is the the current force, and we can call this force actually is there's electromagnetic interactions about this one. Okay, so this is okay. So however you want to combine this together, we got to use another. We got to use another um, very large. This is the strong force over here. So the strong force will confine all the neutron and proton in this region. Okay, so this we call this region is nucleus. Okay, so the strong interaction can be can will have larger will be the largest interaction in these force interactions. Okay, however, the properties of this strong interaction is that he have the so the strong force or we call the strong interaction will not affected by the charge properties. It just affected. Okay, it just actually just affected by the distance between the particles. Okay. So that if you want to combine, you want to combine, you want to take out the neutrons or maybe take out the proton, you got to focus on, uh, you got to make sure that all these strong interaction will be the strong will be comparable. That's okay. So the first is the weak interaction. So the first is a weak interaction is got about the weak interaction rule. The weak interaction means it just can find the radiation decay. Okay, so this is about the decay. And so if something find out there's some decay, it means that the energy will decay and he will finally will be cause some interesting reaction like this one. The neutrons will when we the neutrons happening in weak interaction, so he will cause that there's a positive the protons and the electrons and also the neutrino over here, and the neutrino is kind of very tiny particles, and you have the smallest in this direction turns, and this is the negatives, and this is the positive. So all these terms will be maintained the neutralities, and also these ones. So this is really interesting interaction between this one. That's it. So in the high school textbooks, all the force this force interaction is really important. So there is some compilation and there is some important problems will be happening in your class. that is that the strong force actually is bigger than the coolant force, and also that the coolant force will be bigger than the weak the weak interactions, and also that he will be bigger than the max the gravitation force. Okay, so this is the intensity. This is the intensities of the force that. So after that, the affected region is here. The strongs, the strong force, and the weak force, actually, the strong and the weak force actually is in the nucleus. Okay, so the current force, and the max gravitational force actually he will be infinity. Okay, so he can affect in the scope of the infinity force. Okay, so this is a really important topic. So let's get some recap. Is the first that we have the force. Force we have the force very important fundamental interactions. The gravitational interaction, electromagnetic interaction, the strong interaction, and the weak interactions. And the interesting is that the strong and the weak interaction actually can affect it in the nuclear regions. And the gravitation and the electromagnetic interaction actually can affect the infinities regions. So this is the comparison and also the intensity in magnitudes of the interaction over here. Okay, so this is today's topic about the fundamental interactions. So maybe you will find that there's something very virtual, or maybe cannot understand, because that all these particle actually can be happening in the microscopic scales. So this is really interesting. The ideas of this one, you got to you if you have the you maintain the curiosity of the what is the matters composed, so you will find some. I wish or hope that all of you can find out some interesting about this one. Okay, thank you all of you, and this is today's channels. So see you next time. Bye.